Hi friends, I hope you're doing well. Myself Abhishek Tripathi, and I'm working as a Azure data engineer, and I have a more near about 7 year of experience, and say out of 7 year experience, I have worked with data engineering in 4.5 and written SQL. So I'm going to share a fourth part of the Tata AIG data engineering interview questions, so which is totally based on the Spark file format. So he asked me of 4 to 5 question on this, so I'm going to share, and I think you will love it, and I'm requesting you please like and subscribe my channel for more update. So he asked me question first. I last video I explained how I last video I have explained the what is the if configuration of configuration client mode and cluster mode and all the things difference between. So in this video and also I told about how much data volume I have handled all the things. So he asked me another question. So what will happen when in your database cluster 4 to 5 jobs are running same time? So I told him when multiple job 4 to 5 are running simultaneously, so on a Databricks cluster, so the impact depend on how the cluster is configured. So workload characteristic and the resource demand for the job. So here what happened and how Databricks manage the situation, I'm going to say answer, and whatever I told him I'm going to give you answer same thing here. So first resource sharing. So the cluster resource, CPU, memory, and disk are shared across all the jobs. So each job is assigned a portion of the cluster executor, which are divided among the task of each job. Another potential scenario. So adequate resource. If the cluster has enough resource, large instance type or auto scaling enabled, all jobs can run smoothly. So job will proceed at their expected speed without significant impact on each other. In suppose if insufficient resources on there, so if the cluster lack resource, limited executor or memory, job will complete for them. This can lead to first increase job latency. Job might take longer to complete, or task failure, out of memory error you will get because there is no sufficient memory and there is a lack of resource. That's why it will affect the OM error. And if task cannot acquire sufficient resource, starvation. So some jobs might wait longer in the queue and make slower progress on there. So this is the potential scenario. Another impact on cluster performance. So task parallelism. Task for different jobs might compete for the executor slots, so reducing parallelism. So another part, disk I input output and network bandwidth. So intensive input output operation like shuffle, broadcast join from the multiple jobs may bottleneck disk or network performance on there. So another part, driver overload. If all jobs are all jobs are driven by the same cluster driver, it might become overloaded and causing delay for the delays or failure on there. So how Databricks manage it? How Databricks manage it? So workload isolation. First, workload isolation in high concurrency clusters, workloads can be isolated using pool and resource management on there. Pool and resource management on there. So separate job cluster can be configured to isolate workload fully on there. Either auto scaling. So if auto scaling is enabled, the cluster can dynamically add node to accommodate additional workload. Limits depend on the auto scaling configuration and cloud provider quotas on there. Another part, job scheduling. So job can be prioritized using database job scheduling. Ensure high priority job gets resource first, and after that another job. So best practices for managing multiple jobs on there. So we have to concentrate on the cluster configuration. So first, use high concurrency cluster for lightweight short duration queuing or notebook. Use job specific cluster for heavy workload loads or critical job to prevent resource contention on there. And another auto scaling, enable auto scaling to dynamically adjust resource based on the demands. Another, resource allocation, resources allocation. So set job level configuration for executive memory, core, and partition to ensure efficient resource usage. Use Spark dynamic allocation to scale job resource up and down as needed. So job scheduling isolation. So scheduling job to run during different time windows when possible. Use separate cluster or pool for critical or resource incentive jobs on there. So another for monitor and alert. So monitor job performance using database metrics and log. Set alert for high memory and CPU usage to avoid performance degradation on there. Then another question he asks, there is a sixth job is running in cluster and there is a six worker, and you configured in database, and your current job is running with all the nodes. Now one important job came and need to run immediately. Then what will happen? So I explained the thing, when an important job need to be run immediately in a database cluster that is already full utilized by the sixth job running in the sixth worker, the following scenario could unfold depending on the cluster setup and configuration. So first scenario, shared all purpose cluster, shared all purpose cluster. First, existing resource allocation. So all six worker are fully utilized by the current running job. So the important job will not have any resource to execute immediately. Action required, either we have to manually interrupt or like push the job, terminate the cancel the job, or scale down or one more or lower priority jobs to free up the resources. Either what will happen, the important job will be remain in the queue until resource are available on there. Another part, auto scaling cluster. So I know that my whatever resource I have provided, it is already used, and there is no extra resource available right now, so I cannot add the new job, priority job on this. So what will happen, I try to do dynamic resource, I will do the auto scaling for a particular cluster, auto dynamic resource allocation. If auto scaling is enabled, the cluster can automatically add more node to accommodate the new job provided. The auto scaling limit is not reached, we have to check that sufficient resources are available from the cloud provider. We these 2 point thing we have to consider on there. Then what outcome will come, the new job start immediately on the newly added node while existing job continue unaffected on there. Say third scenario, high concurrency cluster on there. So first session allocation on there. So high concurrency cluster can run multiple jobs concurrently by isolating workload. The new job may start immediately, but it share the same resource, which could slow down all the jobs on there. Another part, dedicated job, either we have dedicated job cluster. So jobs specific cluster, if the important jobs use dedicated cluster, it won't be affected by the existing job. A new cluster will be spun up for the important job, and assuming cluster capacity limit are not reached on there. So preemptive scheduling, another part is preemptive scheduling. So preemption, lower priority job can pushed or terminated automatically or manually to allocate resource to the higher priority job. This approach requires job scheduling mechanism or manual action on there. And best practice for immediate execution important job. So first enable portion is enable auto scaling. Configure the cluster to dynamic scale up when new job are submitted. Another, separate cluster for high priority jobs. Use dedicated cluster for critical job to avoid contention with less important workload. So another part, resource pool. So define resource pool with this reserved capacity for high priority job to ensure immediate execution. And another part, use job scheduling. Implement job priorities using tool like Azure Data Factory, Apache Airflow, Databricks workload to prioritize the important job. And another part is monitor cluster utilization. Use Database Monitor tool to identify resource intensive job and make informed decision about which job to terminate or scale down. So this is the related to job list. Now another question he asks: what are the source file? What are the source file source you have used? So simply I told as a data engineer I worked with a variety of files source to handle diverse data integration and processing requirements. So here are the file source I have used. First CSV, second is JSON, third is Parquet, and fourth is Aviaro, and fifth is text file, and sixth is Delta format. I have used. And the file format which I have not used, I told him simply ORC. Excel I have also used, but directly we cannot read Excel file from the PySpark method. We have to use you have to take the help of pandas to read the things. XML I have not worked. Log files I have not worked. I told simply. Then another question he asked: what is AVRO file? What is AVRO file and how it is different from the other? So I told simply Aviaro is a data serialization framework designed for efficient and compact data storage and exchange. It is particularly well suited for distributed system and big data processing. So I simply told what is the key feature of Aviaro: schema based. So Aviaro files store Avro files store data along with its schema, enabling robust data serialization and deserialization. Schema is defined in JSON format, making it easy to understand and maintain on there. And another second point, compact and efficient. So Avro file use a binary format for data serialization, make it smaller and faster to read and write compared to the text-based format like JSON and CSV. Third, support for schema evaluation. So Avro handle schema changes like adding, removing field gracefully, so making it ideal for dynamic system. So interoperability. So Avro file can processed in multiple programming languages like Python, Java, and Scala. Row oriented. Row oriented storage. So unlike columnar format like Parquet, Avro store data in row oriented manner, which is better for better for write heavy use cases on there. Then he asked when to use a Avro file, on which scenario we have to use, like big data workflow works seamlessly with the tools like Apache Kafka, Hadoop, Spark, Flink. So we can use a Avro file on there. Streaming data ideal for user in streaming system due to its compact size and schema evaluation capability. Inter-system communication, so used for exchanging data between a different system in distributed environment on there. Then I told what is the advantage of a profile. So we can say that efficient serialization, deserialization, smaller file size compared to text-based format, built-in support for schema evaluation, interoperable all access across multiple programming languages. So means we can integrate, we can use in multiple programming language in Avro files on there. So he asked me, is there any disadvantage of Avro file? Then I told him row oriented storage is not optimal for analytics. Means if I want to perform the select statement, want to read, then it will create an issue. It will not optimal for analytics on there. Required schema management, not human readable as it is stored in binary format. So as it is stored in binary format on there. So then another part he asked what is the difference between Avro and other file format. Then I told Avro compact binary format with schema embedded, ideal for streaming and write heavy tasks. Parquet is columnar binary format optimized for analytics and read heavy workload. JSON text based, human readable but large in size, good for APIs and lightweight data. CSV simple tabular format, human readable but lacks schema and comparison. Then then I told him file size. If I'm talking about a file size, Avro and Parquet are smaller than JSON and CSV due to binary encoding on there. Because if you are going to open these two files, it is not a human readable format. Okay, schema, Avro embedded schema, Parquet rely on the external schema. Adjacent CSP have none. Performance, Avro is fast for writing, Parquet is efficient for analytics, JSON and CSP are slower. Readability, JSON and CSP are readable, and Avro and Parquet are not readable. Use case, when to use Avro and when to use Parquet and when to use JSON CSP. So Avro for streaming, Parquet for analytics, JSON and CSP for simple data exchange. Schema evaluation only Avro support backward and forward capability on there. So then he asked another question: what is Parquet? What is Parquet? So Parquet is a columnar storage file format widely used in big data processing. It is designed to handle large scale data efficiently, and it is particularly well suited for analytical workloads on there. So definition means I will give the 1.5 point. Parquet is a columnar storage file format designed for big data processing and analytics. It stores data column by column, make it efficient, and for reading specific column without scanning the entire dataset. Parquet uses advanced comparison technique leading to smaller file size and reduce storage cost. It supports schema evaluation, allowing the addition or modification of the columns while maintaining comparability. Nested data structure like array and maps are handled efficiently. Parquet is optimized for read-heavy workload, making it ideal for analytical queries. It integrates seamlessly. It integrates seamlessly with tools like Spark Hive. Compared to the row-based file format like CSV, Parquet offers better performance and storage efficiency. It is widely used in ATL pipeline and data lakes for scalable big data solution. It compact and optimized design make it go-to format for analytical focused application on there. So they asked me why read faster in Parquet format. Why read faster in Parquet format? Then I told him Parquet read faster because it store data in columnar format, enabling the efficient across to a specific column without scanning the entire data set. The reduce the amount of input output needed for analytical queries focused on the subset of the field. Its columnar comparison reduce file size, speeding up data transfer. Parquet organized the data with metadata, making it easy to skip irrelevant part of the file during reading. It support predicate pushdown, filtering data at the storage level to reduce the rows seed. The binary encoding optimized storage and retrieval compared to the textual file format. Nested structure are efficiently represented, avoiding overhead during access. Parquet stores column data continuously, improve cache performance. Integration with big data tool like Spark leverages parallel reads for high speed processing. These design choice collectively make Parquet much faster for read heavy analytics on them. Then he asked, but your column are distributed. Your column are distributed on all the partition. If you are reading all column, it will have to go to all partitions. Then it will become slow. So reading all column in Parquet does require accessing all partitions, but it remain efficient due to the several factor. So for Parquet compare each column, reducing the amount of the data transfer. The data is read in parallel across partition, leveraging cluster resources efficiently. The format organized column data continuously, optimizing sequential read and minimizing disk input output. Predicate pushdown ensure only relevant rows are scanned even when all columns are needed. Parquet metadata help skipping unnecessary blocks, reducing overhead. Binary encoding further speed up data transfers compared to the text format. While accessing all partition can introduce some latency, the efficiency of the Parquet design ensure it out performance row based format in most scenario. It optimizes storage and processing technique, mitigate the slowdown of the reading from all partition. So the other part is there. What about the updating Avro file, Avro design? What about the updating Avro design for faster writing? So he asked me what about updating Avro because it is designed for faster writing. Then I told him Avro is designed for fast writing and it is optimized for heavy workload, but it doesn't support in place update. Data in Avro file in immutable. So when update are required, you must rewrite the entire file. This involve reading the existing data, applying changes, and writing a new file, which can be inefficient for larger data set. So while Avro is excellent for scenario like logging and streaming, where data is continuously load added, it's not ideal for frequent updates. For update heavy workflow, other format like Delta Lake are more suitable as they support ACID transaction and efficient updates on there. So Avro is best for use cases where data is appended rather than modified on there. The need for full rewrite make update in Avro less efficient compared to the other format. So therefore, while Avro excels in write performance, it not built for the dynamic data update on there. Then another question here. Suppose you have a developed code functionality, how you are doing unit testing automatically. Then I told him simply, whatever code I have developed, I have done the manual testing. Manual testing means nothing but whatever file I'm getting, I have to check I have written the schema functionality and validating the schema. If it is matching with existing, then it is okay. If not matching, then we'll reach a concern. Whatever count is coming, we should be matched with the source and target, and whatever data is coming, it should be matched, and there should be no null, and there we don't no mismatch wrong data on there. So such type of manually I have done. So this is the question which were asked in Tata AIG data engineering interview. So I am requesting you please like and subscribe my channel, so I can create a more video on interview whatever I have given, and it would help you for your exam. Thank you very much for watching. Keep liking, keep subscribing.